Okay, for number one, in the 3D review, it says a solid right circular cone has a base radius of 21 centimeters and a slant height of 35 centimeters. A smaller right circular cone has a height of 12 centimeters and a slant height of 15 centimeters and is removed from the top of the larger cone as shown in the diagram. Letter A says calculate the radius of the base of the cone which has been removed. So the cone that's been removed is kind of outlined on the top of this picture. Now, if we were to draw in the radius here, which I can label as R, look that it forms with the slant height and the regular height a right triangle. So what we can use is the Pythagorean theorem, a squared plus b squared equals c squared, to kind of help us find R. So what I can write is 15 squared, because that's our hypotenuse, equals R squared plus 12 squared. So if I simplify that, it would be 225 equals R squared plus 144. Now we need to get R by itself, so I would subtract 144 from both sides. When I do that, I would get 81 equals R squared. And to get rid of the squared, we would take the square root of both sides. And the square root of 81 is 9. So the radius would be 9 centimeters. Number two, calculate the curved surface area of the cone which has been removed. So we're still focusing on that top portion. Now the curved surface area of the cone, we need to go to our formula booklet to check that out. And if we scroll down to where all of these different formulas are, the curved surface area of the cone is right here. A equals pi RL, where R is the radius and L is the slant height. Okay? So if I go back, we're going to be using this equation, A equals pi RL. We now know the radius is 9. We know the slant height they give us in the picture is 15. So we're going to, A is going to equal pi times 9 times 15. We can type that into our calculators. We always want to actually use the pi symbol, which to get that is second and the caret button, times 9 times 15. Now we get a very long decimal. Remember, your two options for your answers are either writing the entire answer down or you can round it to 3 sig figs, which if I do that in this case, it would just be 424. So our answer for the curved surface area of that top cone would be 424 centimeters squared. The last part then, calculate the curved surface area of the remaining solid. Now that's kind of tricky, but what we can do is find the curved surface area of the entire cone, including the part that was removed, and then subtract that curved surface area. So again, we're going to be using this equation, and we'll do it for the entire cone. So the radius of the entire cone is 21, and the slant height is 35. So it'd be pi times 21 times 35. But then we would have to subtract the curved surface area of the part that was removed. So I'm going to subtract 424. And that would get us our curved surface area of the remaining piece. So I'll type that in. And then I would subtract 424. So we're left with 1,885.0706. And again, that is centimeters squared.